Hello there, and welcome to LabHub back. So today we're gonna talk about a really easy topic. I think the easiest one in a whole intermediate block. This is the springs. And for the springs, you will need only few formulas. And if we're talking about it, like in general, it's only two formulas you need. So let's get started. The first one is force applied on the spring equals to K times delta L. Or another version of it is force equals Kx. All right, let's do it step by step. What is F? We already know it. This is the force, yeah? And this is the force, in our case, applied on a spring, right? We can represent it like this. We got some spring, right? And here is a wooden table. Why not? And we apply some force on this spring, right? Eventually, it moves. And it moves right here. We applied some force and it moved, right? So then, what is T sines, huh? Logically, we know that L is length, right? Right. So then, delta L is change in length. So, delta L equals L original minus L final, right? So L original is the whole length of the spring, and L final, this part. So through this equation, we estimate this part, change in length, right? We estimate how far we pushed this spring. So therefore, what is K? K is an interruption part. It called the spring constant, and it's not constant at all. For each spring, there is each constant, and there is no exact formula for it. It's usually given in a problem, or you need to find it. So So the K equals F divided by X, or by delta L. This is not a big matter. I used to use this thing, delta L. So basically, this is all you need to know on high school level. But in some problems, you will need to find kinetic energy of maybe some airsoft ball, right? They were shot from some airsoft gun, and this gun usually includes a spring. So we need to find the work of the spring or the energy of the spring. How can we do it? We know that formula of kinetic energy is 0.5 times mass times velocity squared. But in case of springs, to find kinetic energy, this is 0.5 times K times delta L squared. So now, this is really all you need to know about springs. This equation will be used barely, really barely. You won't use it. You probably will get one lesson on it and one problem on your test where you should apply this formula and no more, literally. Whenever this equation, because this is the one equation, you will use really a lot in a school level of physics, maybe on your engineering degree, because This is the classic, this is the kinematics, and you probably will use it. So this is necessary part of the mechanical physics, of the kinematics. So basically, this is all you need to know about the springs.